We finished 7.1 and 7.2, right?
Yes.
Okay. So in this lesson, we are going to start 7.3 magnitude and direction. Write the title. I'll explain this. Listen to me. Let's take a vector. AB vector is 3, 4, let's say. Or you can write this way also, 3i plus 4j, right?
Yeah.
I'm gonna draw the vector from A. You go 3 units to the right, 4 units to the top. This is the vector AB vector, right? This is 3 units, this 4 units. The magnitude of the vector is denoted by modulus AB. This is nothing but the length of the line AB. How do you find the length of the line AB?
You do 3 plus 4.
3. Did you just say 3 plus 4?
No, like 3i plus 4j.
No, that's a vector actually. I'm talking about here. How do you find the length of AB, the line AB? Let's not think it as a vector. It's just a straight line. How do you find this length? You complete the triangle. Right angle.
Can you use Pythagoras theorem?
Pythagoras theorem, wonderful. Okay, so when you use Pythagoras theorem, this is going to be square root of 3 square plus 4 square, right? So in general, AB, the magnitude of AB vector is square root of x square plus y square. Understand?
Why is the AB in modulus?
That's the notation for magnitude actually. This is called the magnitude of the vector.
So it's not modulus.
It is modulus. You see, I put a modulus here. Magnitude means modulus of AB. How do you find the magnitude? You take the x component and y component, apply this rule, square root of x square plus y square. That's how you find the magnitude of any vector. Understand what I'm saying?
Okay. Yeah.
Yep, copy that. And then the next thing is magnitude and then unit vector. Okay, just write the title unit vector. Okay, let's say you have a vector now, A vector. I'm gonna call it A. Let's say AB vector. Okay, if they ask you to find the unit vector, let's say the length of this vector AB vector is 5. Modulus AB is equal to 5. Okay, to find the unit vector, you take the vector divided by the length. The notation is AB vector. Usually, if let's say A, we put this symbol on top. You can call it A cap or A hat. Okay, A hat is equal to A over modulus A. That's the formula to find the unit vector, and you are going to get.
But why would you even need to find the unit vector? Like, what is that for?
Sorry, why?
Why do you need to find the unit vector?
If you are asked to find the unit vector, you have to find it, right? That's just a separate question. Sometimes you'll be given a vector, they are going to ask you to find the unit vector. This is the formula.
Oh, okay.
Okay, copy that please.
Okay, I have it down.
And the next thing, to find the angle that the vector makes with the positive x-axis. Let's say your x-axis is here. Okay, let's say this is the vector A to B, and you need to find this angle. This angle is, if you complete this triangle, this theta is same as this theta, right? Because these two lines are parallel.
Yeah.
Okay, this is x, this is y. Let's say AB vector is equal to xi plus yj. Can you tell me how do you find theta now from the triangle?
Would you use the cos rule?
You use Sokotowa because it's a right angle triangle, right?
Yeah.
So tan theta is going to be opposite by adjacent. So theta is tan inverse of y over x. Understand? That's the formula to find the angle that the vector makes with the positive x-axis. Copy that, please.
But it wouldn't always be tan, right?
Yeah, it will always be tan, because from the right angle triangle, how do you find theta? You have opposite side and adjacent, right?
Okay.
So it will always be theta. So I'm going to go to exercise 7C. You copied this?
Oh, just 1 second. Okay.
Exercise 7C. Question number 1 is a simple one. You can just find the magnitude of each of those vectors. I'm going to move on to question number 2. Question number 2 is this. You have 3 vectors given A, B, C. Find the exact value of the magnitude of A plus B. So basically, first find A plus B. A is 2, 3. I'm going to put it in the matrix form, so easy to add. B is this. So A plus B is 5 minus 1, right?
Yes.
So modulus of A plus B is square root of 5 square plus negative 1 square. That's a rule we learned just now, right? Which is square root of 26. Understand?
Yeah.
For B, you find 2A minus C. 2A minus C.
Sir, just give me 1 second. Someone's at the door.
Yep. You have to multiply by 2. So you'll get 4 minus 5. 6 plus 1, isn't it? Negative 1 and 7, right? Understand?
Yeah.
So modulus 2A minus C is equal to square root of minus 1 whole square plus 7 square, which is square root of 50. Put it in your calculator. I think you will get 5 root. You cannot write it as square root of 50. You always need to write it as a simplified form. 5 root.
Okay. Okay, I have it now.
Okay, let's look at this question. Question number 3. For each of the vectors below, find the unit vector in the same direction. For example, A, the unit vector, the notation is A kappa. A hat is A over modulus A. So take the vector 4i plus 3j divided by modulus A is square root of 4 square plus 3 square, which is 16 plus 9, 25 is 5. So you can write it as 4 over 5i, 3 over 5j. Do you understand this step?
Can you explain the second step again?
You see, you understand the formula on this, right?
Wait, can you explain the denominator part of that?
Denominator part, how do you find modulus A? What's the formula you just learned? Magnitude, right? How do you find the modulus of a vector? You just need to square it within square root, right? That's the same thing. You take the vector, so you put it as square root of 4 square plus 3 square. Understand?
Okay. Yeah.
Okay. And then you calculate it, you will get 5. Square root of 25 is 5. So divide each component by 5 separately. Do you get it?
Just sorry, sir, 1 second, my brother's saying. Wait, so where did the 5 come from?
What's the value of this? That's 5, right?
Yeah, 5.
So you divide
okay,
each
then
component by
yeah, you simplify that and then you divide
Yes.
it. Okay.
So I minus 3j, I'm doing D now, divided by square root of 1 square plus minus 3 square. You will get square root of 10 at the bottom. So 1 over square root of 10i minus 3 over square root of 10j. Copy that, please. Okay, copy. You copied this?
Nearly just 1 second. Okay.
Question number 4. Read the question. It says, find the angle that each of these vectors make with the positive x-axis. If you look at this question, the x component is positive 3, y component is positive 4, right? So from a point, you need to go 3 units to the right, 4 units to the top. So the vector is this. This is the vector. Okay?
Yes.
So let's say your x-axis is in here or it can be anywhere. This angle is same as this angle, right?
Yeah.
So to find this angle, you apply the formula you learned. X is equal to tan inverse of 4/3. This is 3, this is 4, right? So find the tan inverse of 4/3 to 3 significant figure. You will get 53.1 degree. Do you understand this?
Yeah.
I'm going to show you one more. Listen to me carefully now. So for this one, you can just draw this figure. Theta is here, 3, 4, right? Look at the second one. 6 to the right, 6 units to the right, 8 units below, right?
Yeah.
So this is 6 and 8. In fact, take the length as positive 8, even though it's negative, okay? And the theta is here. Let's say this is your x-axis. You can write tan theta is equal to 8/6. Theta is tan inverse of 8/6. But the angle is below, right?
Yes.
So 8/6 is same as 4/3. So you'll get 53.1 degree below. Just put below. Here you can put above x-axis or simply above.
So below it wouldn't be negative?
It will be negative. You can just simply write it as just below.
Okay.
Okay, that's fine. Copy that.
And they allow that in?
Yeah, they allow that. First of all, you won't get questions like this, kid. It's just you are just trying to understand the basics actually. Copy that. Now let's look at this question, exam style question. Question number 8. Given that modulus 2i minus kj is 2 square root of 10, find the exact value of k. How do we find the modulus of this vector? Square root of 2 square plus minus k whole square, right? That's how you find modulus of any vector, right?
Yeah.
So it's going to be 4 plus k square is equal to 2 square root of 10. You square both sides. The square root will be gone. 2 becomes 2 square. Square root of 10 becomes just 10. So k square is equal to 40 minus 4, 36. K is equal to plus or minus square root of 36. They did not specifically say whether k is positive or negative, so there are two values. Copy that.
Could you explain the third step again?
This step,
Yeah.
square both sides. So here the square root will be gone. The other side, 2 square is 4. Square root of 10 square is 10.
Okay. I
Okay.
understood that.
I'm taking one last question from this exercise, question number 11. If you look at the marking scheme of this question, you are going to get headache actually. Okay, so don't look at the marking scheme. Just let's apply whatever things we have learned so far. They want you to find the size of the angle QPR. This angle, right? I'm going to take it as theta. Okay. We are given the vector PQ, so we can find the length of the vector, right? Which is modulus PQ is square root of 4 square plus 1 square, square root of 17. That's the length of PQ. And we can find the length of PR vector, right? Which is square root of 6 square plus minus 8 whole square. You will get 36 plus 64, 100. Square root of 100 is 10. PR is 10. Now can you tell me how do you find QR vector from the figure?
QR.
You need to
You could go from QP
Yes.
to PR.
Exactly. QP plus PR, right?
Yeah.
You know PQ, so QP will be negative of it, right? Minus 4 minus 1 plus PR is 6 minus 8. You will get 2 minus 9, right? So modulus, the length of QR is modulus QR is square root of 2 square plus minus 9 whole square. 81 square root of 85. This length is square root of 85. Now I want you to look at the triangle and tell me, how do you find theta now from this triangle? It's not a right angle triangle, it's just some random triangle.
Yeah, you can use the cosine rule.
Perfect. You use cosine rule to find theta. Okay, that's a lot easier. If you look at the marking scheme, they have done so many stuffs. Actually, it's giving you a headache. Okay, it's going to give you a headache, so just forget about it. Apply that cosine rule. I want you to copy this whole thing first.
That's supposed to be PR, right? The 6 squared plus minus 8 squared.
Yeah, sorry, it's PR. Now we are going to apply the cosine rule by taking the opposite side as C, other two sides as A and B. C square. Okay, copy that.
Okay, I have it done.
Okay, the cosine rule is this: C square is equal to A square plus B square minus 2AB cos theta, and then we make theta as a subject, right?
Yes.
Just plug in the values here and make theta as a subject. Can you find it now? C square is going to be just 85, A square is 17, B square is 100 minus 2 square root of 17 times 10 times cos theta. So the cos theta is going to be 17 plus 100 minus 85 divided by 2 square root of 17 times 10. Find the value of it, then find the inverse of it. That's cos inverse of this. They want the answer in degree to 1 decimal place.
Yeah, so 67.2.
67.2 is the right answer. 67.2 degree. Okay, you understand this?
Yeah.
Okay, how do you find the area of the triangle now?
Half AB sine C.
Sine C, very good. Half AB are the two adjacent sides of the angle. Sine 67 point blah blah, the actual value you got.
Yeah.
Okay, so I got 19 as the answer. 19 square units. So that's the end of this topic.